This Unreal Engine 5.5 demo writes score 75 to a real SaveGame slot on disk. It then deliberately changes the live score to 5 while the slot still contains 75. Finally, LoadGameFromSlot reads the saved object and restores the live score to 75. In this lesson, we will define a USaveGame subclass, mark persistent fields, create and populate a save object, write a named slot, separate live state from persisted state, load and cast the result, validate a save version, and proof the full round trip with a real.save file, native runtime frames, exact logs, and automation. Score SaveGame derives from USaveGame and declares two persistent properties, saved score and save version. The SaveGame property specifier documents that these fields belong to the save schema. Keep this class focused on data. The runtime actor owns presentation, timers, and the current score. The save object owns the snapshot that can cross sessions. This separation makes serialization easier to reason about and keeps scene components, world pointers, and transient behavior out of the persisted format. When the timer fires, the demo sets the live score to 75 and calls create SaveGame object with score SaveGame static class. It casts the returned base pointer to the expected schema, copies the score, and writes version 1. Creating the object does not write a file. It only builds an in-memory snapshot. Populate every field deliberately, check the cast, and decide how your project handles defaults, missing optional data, and schema upgrades before calling the disk API. SaveGameToSlot serializes the object under CPP tutorial score slot with user index 0. The Boolean return value is stored and logged. Unreal writes CPP tutorial score slot.save in the project's saved SaveGames directory for this desktop run. A slot name is an application-level key, not a raw cross-platform file path. Define naming and user index policies centrally. For larger saves or shipping games, also consider asynchronous save APIs so disk work does not block an important frame. After the save succeeds, the demo changes only the live actor score to 5. The score bar becomes short and red, but the separate slot indicator stays green because the save file still exists. The runtime log reports lev score 5, slot score 75, and slot exists true. This step is important evidence. If we loaded immediately after saving, a matching value could be mistaken for unchanged memory. By forcing live state away from the saved value, the later restoration proves that persisted data actually influenced the actor. LoadGameFromSlot reads the named entry and returns a USaveGame pointer. The demo casts it to score SaveGame, checks that save version equals 1, clamps the loaded score, and applies 75 back to live state. The bar grows and turns green. In production, validate class, version, ranges, identifiers, and dependencies before mutating the world. Missing or incompatible data should follow an explicit fallback or migration path instead of being trusted blindly. These are real game mode captures from SaveGame demo map. First, the yellow score bar shows save to slot, score 75, and the green cube confirms that the slot exists. Next, the red short bar shows live score 5 while slot has 75. Finally, LoadGameFromSlot restores a green score bar at 75. The actual save file remains on disk, and the visual states match the exact save, mutate, and load log sequence. Automation creates a separate score SaveGame object with score 42 and version automation. It writes a real test slot, confirms that the slot exists, loads the expected class, compares both fields, deletes the slot, and confirms removal. The runtime uses a different persistent slot and finishes with save true, load true, slot exists true, live score 75, disk score 75, version 1, and valid true. The test passed with 1 success and 0 failures. The reusable pattern has 5 steps. Create the correct save class. Fill a snapshot from current state. Save it to a deliberate slot. Load and cast the returned object. Validate before applying values back to gameplay. Persist identifiers and durable state, not temporary world pointers. Plan versioning and migrations early, test missing and corrupted entries, isolate slots between users or profiles, and prefer asynchronous work when payloads grow. A successful API call is only one gate. A reliable save system also proves that the restored game state is correct.